Hello and welcome back, Tech Stalkers. In today's video, we will be talking about ellipses. So let's get into it. Ellipses is a very simple topic. We will solve three examples, and before we get to work with the questions, let's just explain something about ellipses. Alright, so initially, let me tell you something. We can have a vertical ellipse. Okay, this is not perfect, but it still do. And a horizontal ellipse. Alright. Now here, this point and this point, we call these the vertices of the ellipse, okay? And through the vertices, there is an axis called the major axis. Alright. And this is the center of the ellipse. It is HK. Alright. And we have something called co-vertices. They are at the same level with the center, except the minor axis goes through these co-vertices. Alright, so there is something you need to know about the ellipse. Before we talk about the ABC, we have two foci, this and this. Alright, so when we're talking about this distance of red color, okay, which is half the major axis, this is represented as the letter A. So you can guess that the whole major axis is 2A. Alright? Now to the minor axis, half the minor axis is B. And you guessed it, the whole minor axis is 2B. Now what is the letter C? C is the distance from the foci to the center, and this is C. And the distance from one foci to the other is 2C. Right? Yeah. And the same thing repeats for the, oh my gosh. Okay, for the the horizontal ellipse, but everything is reversed. So the major axis is now horizontal and the minor axis is now vertical. And you need to know that the foci always lies on the major axis. The same, everything stays the same. This is C. The distance from here to here is A. And the distance from here to here is B. Now, how do I know before telling you how to know if it's like a vertical ellipse or a horizontal ellipse, let's look at the table. So, as you see, the table has the equation of the ellipse that has the center 0, 0. Alright, so in this case, the center is the origin 0, 0. Alright, now H and K is for the other table when it's not 0, 0. Right, so when it's 0, 0, when you see this equation with no numbers and parentheses or brackets at the top here, that means that the center of the ellipse is 0, 0. Alright? And how do I know if it was a horizontal ellipse or a vertical one? Well, didn't I tell you that A represents the major axis, the longest one, right? So if the A is under the x, that means it is a horizontal ellipse. If the a is under the y, the a squared, sorry, is under the y, it is a vertical ellipse. Simple, right? Remember, x is for the x-axis, which is horizontal. That means if the a squared under the x is under the x, that means that we have a horizontal ellipse. If the a squared is below the y squared, we have a vertical ellipse. And as I told you, the length of the major axis is 2a units, and the length of the minor axis, which is in blue, is 2b units. The foci, what is the foci? So, if its origin at 0, 0, you just have to follow this formula. Just memorize it, but if you explore it more on the graph, you'd get the idea, because your center, let's say we have a horizontal ellipse. Okay, your center is 0, 0. Let's say my foci, alright, is here at 3, 0. The y is 0, that means we're on the same level, and here at -3, 0. But when it is vertical, it changes, right? The y only changes, the x stays the same. So, right? So let's remove all of that for now, because we want to solve a question. I removed my question. Alright, before moving to the question, what is it about that other table down below? This is just for when you have the center not 0, 0. If it's not 0, 0, you follow the formulas in this table, alright? And the same thing, if the a is under the bracket with the x, it is horizontal. If it's under the bracket with the y, it's vertical. And you just have to follow these expressions to get to the answer. Alright? So, for the first question, we have here, write an equation for the ellipse. Now, as you can see, the ellipse has its center at 0, 0, right? So we're going to use this table. Now, alright. So in order for us to find, write the equation, there is something that we will use, which is this equation. C squared equals A squared minus B squared, right? And the ellipse equation, as you can see, it's a vertical ellipse, so we will use this formula. We will use y squared over a squared plus x squared over b squared equals 1. The equal 1 does not change in any of your ellipse equation. So, remember, it is vertical. That's why we chose this equation, which has the a squared under the y squared, alright? Now, they gave us the origin, but hey, they also gave us the vertices, right? So, this is A. As you can see, if this 0 is 0, 0, okay, and we have a vertical ellipse, let's subtract 9 minus 1 is equal to 9. Minus 0 is equal to 9, right? That means our A is 9, because see, the center is 0, 0, and the vertex is 9, units away, right? So A, now we know that A is equal to 9. All right, what about C? Okay, A is actually supposed to be red, so we don't get mixed up. Okay, C is, as you see here, this point is the foci. Sorry, the focus. One of the foci, alright? So from 0, 0 to the focus, okay, so from the origin to -7, we got down 7 units, right? And similarly, from here, from 0, 0 to 0, 7, it is 7 units, right? That means C is 7. Now we haven't got B, yeah? As you can see, it's not precise, right? The B's, by the way, are the one here. All right, so I'm gonna use this formula. To find my B. But first, let me rearrange it. So C squared equals A squared minus B squared. All right, I want the B squared part to begin with. All right, so I will move the A to the other side, right? So now I have C squared minus A squared. All right. Now, if I divide each side by -1 to remove this minus, so this minus goes with this, and I will flip the signs in this part. Okay, so now I have B squared is equal to, if I have minus C squared plus A squared, we can rearrange that to write A squared minus C squared, so it looks nice, okay, and more tidy. Now, I don't really want B, I want B squared, so I can substitute it straight in this equation, right? So let's substitute the values. Now I have 9 squared minus 7 squared, that is 81 minus 49. Now use your calculator to find B squared. B squared is 32. Now we know that A squared is 81. We know that B squared is 32. Right? Now we can write our equation. So let me go down. So I will use this equation. Y squared over, what is A squared? It's 81, because 9 squared is 81, plus x squared. What is B squared? B squared is 32 equals 1. The only thing we changed is A squared, which became 81, and B squared, which became 32, and it's all similar to the rest is all similar to the equation here. All right, so that was the answer of this question. Now let's move to the other question. Write an equation for the ellipse with the vertices 6 minus 8, 6, 4, and the co-vertices 3 minus 2, 9 minus 2. All right, so let's imagine a grid here. All right, and clearly because we don't have any zeros here or here in the vertices, and we don't have any zeros in the co-vertices. Sorry. That means our center is not 0, 0. Our center is HK. All right. So we will use this table. Now, let's see. The vertices, okay, which are at the ends of the long axis, has the coordinates 6, -8, and 6, 4. Now, the x does not change, right? But the y changes. That means when the y changes, that means we have a vertical ellipse. If for the vertices, if the y changes and the x stays the same, we have a vertical ellipse, right? 6, 4, 6 -8 at the center. Okay, it should not be the origin. Something here. And the center must be here, HK, right? Now they told me, so this is my major axis, and they told me for the minor axis, I have 3 - 2 and 9 - 2, or -2. Okay, this is not the scale because I actually put the coordinate is supposed to be 3 - 2. Yeah, but this is not 3 - 2 at this point. All right, so this is not scale. And 9 - 2. All right. Now you can follow the formulas here to find h and k, but let me tell you a trick. Okay, see the number that does not change in the vertices? It's the x, right? Whatever. We have h and k, right? Take the number that does not change in the vertices. If it was x, it will be the h of the center. If it was y, it will be the k of the center. In this case, we have 6 that does not change in the vertices, and it's in the x position. That means it will be in the h position. It will be the h x value of the center. All right. For the co-vertices, the -2 does not change, and the -2 is the y, right? So we will put it instead of the y of the center, which is the k. All right, so the k is -2. Or if you did not understand this method, you can refer to the table. Yeah, so you can refer to the table and do your calculations, but this is just a trick to do. It will save you a lot of time. All right, so now we got our HK, the center, all right? So let's figure out the A and the B. So for the A, we will take the Y, the one that changes, all right? We will do is 4 minus 8. 4, so 4 minus 8, this is 2a. This is the length of the whole major axis, all right? 4 minus 8 is 4 plus 8, all right? And this is 12. Now, that means 8 is 6. If you divide both sides by 2, right? That means 8 is 6. Where did we get this 4 and this 8? The 4 and the 8, all right? And also, if you do it the other way, minus 8 plus 4, you're gonna have minus 6. Here we don't really care about the sign, we care about the units. All right, so this is the 6. If we do minus 8 minus 4, all right, we'll get minus 12 as 2a. And if we divide by 2, we'll get minus 6. But we really care about the units, not the sign. So whatever operation you do on this, if you plus them or if you minus them, you're gonna get at the end to the one result, which is a is equal to 6. You know, so if you do 4 minus 8 or minus 8 minus 4, yeah, if you change these two, doesn't matter. Whatever. Now we're done with the a, so now let's look at the values that change in the x. All right, so we have in the x and the b, right? So 9 minus 3 over 2 is equal to 6 over 2 is equal to 3. Yeah, how do I confirm this? Well, look, the center or the x of the center is 6. All right, how do I get 3 minus 2 instead of 6 minus 2? I go to the left 3 units. How do I get 9 minus 2? I go to the right 3 units. Yeah, there's a lot of ways that you can figure this out. But now we just figured out that b is 3. Now let's write our equation. And remember that this equation, this one right here, is the one for the vertical ellipse. Now let's remove all of these calculations to make a space for our equation. All right, I just want to keep the value of a, which was 6. Y minus k squared plus x minus h squared b over b2 b squared, sorry, equals 1. All right, so text talker, how on earth do I know that this is the equation of the vertical ellipse? Well, look at the a squared. It's under the bracket or the parentheses that has y in them, right? Anything that has to do with y is vertical, right? So remember this. So now let's just substitute y minus k. What is my k? We agreed that our center was 6 minus 2. All right, so 6 and minus 2. My k is minus 2, and I have a minus. So minus minus 2 becomes plus 2. All right, what is my a? My a is 6. What is 6 squared? A squared equals 6 squared. 6 squared is 36. Let's remove the a because we're done with the a. Now add the plus sign. Don't forget the square on both parentheses. Now what's the h? The h is 6. Let's square the bracket. And what's b? B is 3. What's b squared? 3 squared is 9 equals 1, and that was my equation. If you think that you need to rewind this and watch it again, please do. All right, this question is a little different. what we're doing in this question is we are rewriting this equation to be in the standard form. This is an equation of an ellipse. If you put it in decimals, you will get the ellipse. But say you want to graph it by yourself, it would be better to put it in the standard form. This is what this question asks us to do. So we will do simplifications. We will move, for example, we will move this 436. This is a constant to the other side, so we will do minus 436. All right. This is a plus here, so it becomes a minus on the other side. And now let's work with this side. Now let me tell you something about this. Always when you work with these kind of equations, put the x's next to the x's and the y's next to the y's. Let's do 25x squared plus 250x. Okay, let's remove this, we need space. 250x minus, or plus, 9y squared minus 36y. One second. All right. Now we are going to look for common factors. So a common factor to take here is 25 and 25. So if we took 25 out, we have x squared plus 10x. All right, plus if we took 9 here, we have 9y squared. What is minus 36 plus divided by 9, by a positive 9? Yes, it is negative 4. So we have negative 4y here is equal to minus 436, the constant that we moved. All right, now we're going to complete the square. If you don't know what's completing the square, please refer to my previous videos and then come back to this video. So now we're going to complete the square. We're going to leave the numbers outside the parentheses as they are. X squared plus 10x. Okay, what is 10 divided by 2? It's 5, right? What's 5 squared? It's 25. So we're going to rewrite the same thing the same way, except we're going to add 25 here, plus we leave the 9 alone. What's inside the bracket? So we put the y squared as it is, minus 4y. What is 4 divided by minus 4 divided by 2? It's minus 2. Minus 2 squared is 4. So we add 4. Now we need minus 436. We added these here. We need to add them on the other side as well, right? So, but remember to multiply this with this and then add it. Yeah, so plus 25 into 25, and this one as well, plus 9 into 4. All right, you can't tell the 9 from the 4 here, whatever. Now we leave the 25. Let me use another color so we don't get mixed up. So we leave the 25 as it is for now. We need to turn this into a perfect square. So we leave the x as it is. We bring down the x. We look at the signs. 2 pluses means we have a plus here. What is the square root of 25? It is 5, and we put the square outside. Plus, we leave the 9 alone for now. We open the parentheses, we bring down the y. How many pluses do we have? We have 1 minus, 1 plus, minus wins. Alright, what is the square root of 4? It's 2. Okay, and we put the square outside. Now you want to put this into your calculator to get the result. So I will put minus 436 plus 25 into 25 plus 9 into 4. This will give me 225. All right, are we done yet? Not yet, but almost there. All right, so now we want this side to be 1, right? We want this to be 1 in order for it to look like to look like this over this equation, right? Because all the ellipse equations end with 1, right? So what we will do to turn this 225 into 1, we will divide it by itself. Yeah, so 225 divided by 225 is equal to 1. Now, when I do this, I will do this to this side as well. And remember, if you have something and then a plus and then something and you want to divide, you will divide this side and this side, like this whole term and this whole term. Okay, because there's a plus between them, or even a minus. They are separated. Okay, so 20, we can cancel these, right? 25 is a factor of 225. Now, to get what is left at the denominator here, do 225 divided by, or divide both sides by 25, right? Okay, so, and divide this by 25 as well. So this goes with this, and 225 divided by 25 is 9. Okay, so this goes with this, and what's left is 9. All right, and if you divide here, okay, so let's write this first so we're not mixed up. So this canceled with this. Now what's left is x plus 5 squared over 9 plus. All right, going back here, we want to take this 9 away. So we will divide it by 9. 9 goes with 9. We will divide this also by 9. So 2 to 5, this is not 255, it is 225. Okay, divided by 9 is 25. Yeah, so what's left here is 25. So y minus 2, I need to change the color, y minus 2 squared, what, a 2, okay, over 25 equals 1, and voila, this is my equation. If you think that you need to rewatch this, please rewind and watch it 2, 3, 4 times until you understand the idea. Now, I will not be talking about graphing a lot. You can just throw this into the calculator and the graphing calculator, and it will graph it for you. Or you can use the method I spoke about in the beginning of the video. So you can use Desmos for that. I don't want to make this video longer. Thank you for watching. I might upload graphing videos later on, but thank you for watching this video for now. I hope you liked it and understood the main concept. I hope you are able now to solve ellipse questions. Please leave a like, subscribe, and I will see you guys in the next video.